So whenever like LPC 2148 is a microcontroller. It's a microcontroller. And it wants to talk to some other IC, or for example, it wants to talk to personal computer like laptop. Then see, both LPC 2148 and laptops should understand some common language so that like it can communicate with each other. So for that, we have something called UART, the communication protocol, what we use called UART. So the UART is like both the other device, I mean like the microcontroller and the other device, both which can understand and communicate with each other. So the UART stands for Universal Asynchronous Receiver and Transmitter. So when I say it's a common language, and here there is a term called asynchronous. The meaning of asynchronous is, so usually whenever I want to transmit a data, like if I'm sending a data, like one pulse, to assume I send one pulse from TX to RX. So the RX side, so this is like LPC 2148 sent, and the laptop should decode this. So he can read this as 0, 1, 1, 0, 0, or he can read this as like 0, 1, 0. Many ways to interrupt this, right? Interpret this. So usually in the synchronous communication, what will happen? Along with the data, we also transmit clock. This is in the synchronous communication. So here, what happens? At the receiver end, you will check the data at every rising edge of the clock. So this will be interpreted as 0. This will be interpreted as 1. And this will be interpreted as 0. So actually, in the universal asynchronous receiver or transmitter, what happens? Both TX and RX knows what is the frequency of it. Okay, we call it as baud rate. So both has to be set at that baud rate. For example, here if I set 9600 is the baud rate, here also it should know 9600 is the baud rate. Okay, so when we do this, what is going to happen is, so it is going to use some same clock 9600 or 19200 clock, and according to it, right? So it is going to sample the data. So in the universal asynchronous receiver or transmitter, we are not going to send this clock. Both will know what is the frequency of this clock so that receiver and transmitter can understand that data correctly. And in general, whenever we want to transmit the data, we have various ways. So we can, like if I want to transmit 8 bit of data, like 0x AA. So in binary it is 10101010. I can serially transmit one by bit, but the issue is when I transmit serially, it will be very slow. Instead of that, another what I can do, I can have parallel 8 bits, 8 pins. I can transmit parallelly, but it requires more pins, but it is faster. So usually this UART communication, right, that will happen through, there is a port in the computer called COM port. So through that it will happen, but in the newer PC, we will not have this COM port. So usually what we will do, we will have UART to RS-232 converter. So through that we communicate. Okay. So whenever I transmit the data through UART, right, I will have, first I will have something called start bit 0. This is called start bit because the receiver should know when the data starts. That is where my start, at the start bit, my data will start. Then I will have 8 bit of data. Then I will have parity bit. So parity bit is nothing but what I do, like I have 8 bit of data, right? I XOR all the bits and I make it as a parity bit. This is basically to check the error. For example, if I have 1 0 1 0 1 0 1 0 AA as the data, when I XOR, right, 1 0 XOR is 1, 1 1 XOR 0, 0 1 1, 1 1 0, 1 0 1, 1 1 0, 0 0 0. You are going to get parity as 0. So if, for example, while transmitting, this bit became 0. Now if we XOR 1 0 0 1, 1 1 0, 0 0 0, 0 0 0, 0 1 1, 1 0 1, 1 1 0. Okay, somewhere I missed. This is like 1 0 0, previously 1 1 0 0. Now I change. So 1 0 1, 1 1 0, 0 0 0, 0 0 0, 0 0 0, 0 1 1, 1 0 1. So I'll get parity 1. So whenever this parity and received bit parity doesn't match, it means we got error. So then we will have 2 bits of stop bit, so which indicates we are stopping at that point. We finished receiving the data. So this is the format in which the data gets transmitted in UART. So in LPC 2148, right? Two UARTs are there. One is UART 0 and UART 1. So UART 0 is actually at, we have TX connected to P0.0, RX connected to P0.1. Same way, for UART 1, TX is connected to P0.8, RX connected to P0.9. So here, both UART, right, it can receive 16 bytes at a time. Okay, it has an internal FIFO. So 16 bytes at a time it can receive. So it can store up to 16 bytes of data. Usually it will be stored in TX buff, RX buff register. So for transmission purpose, right, we have two registers. One is THR register, transmit hold register, and transmit shift register, TSR. For receive, we have receive buffer register, receive RB, R, and receive shift register, RSR. So here, first data, right? Whenever you want to transmit, it will be there in transmit hold register. Then it will be shifted to transmit shift register. In the receive, initially it will receive in the transmit receive register. Then it will be moved to RBR. This is the so some of the important registers: U0 RBR, receive buffer register, which is used for holding the RX byte. So same way we have TH star, transmit hold register. So for controlling the baud rate, the data rate, we have something called DLL and DLM module, where we can set the clock frequency. Then we have interrupt enable register. Whenever a certain interrupt comes, that is data received, or when data transmit, we can generate some interrupt. That interrupt enable register we can use for enabling that. And I mentioned this is the general format, right? The data format. So if you want to change this data format also, we have something called the line control register, LCR. So you can select what kind of format you want. For example, of LCR 1 down to 0 bits, right? So it decides what should be word length. So this 8-bit, right? I said this is 8-bit, but actually speaking, it is 5 to 8-bit operations pattern. Okay. And whether you want one stop bit or two stop bit, that is bit 2 can support that. Whether you want to disable the parity, bit 3 can support that. And you can actually say that like odd parity, one parity, forced one, forced zero parity, that also you can select. And basically 7th bit, it says like divisor slash access. So we can read the status of that and see that like what is the baud rate frequency. Okay.
Yes, sir.